Hi, my name is Farid Shahiran bin Muhammad Rizal and my matrix number is CD190067 and my part is experimental theory. So, a tensile test is also known as a tension test. Is probably a most fundamental type of mechanical test that can be performed on material. Tensile tests are simple, relatively inexpensive and fully standardized. By pulling on something, you will very quickly determine how the material will react to force being applied in tension. As the material is being pulled, you will find its strength along how much will elongate. You can learn a lot about a material from tensile testing as you continue to pull on the material until it breaks. A complete tensile profile will be obtained. A curve showing how it reacted to the force being applied is produced. The point of failure, typically called its ultimate strength or UTS on the chart. So, the example for the graph is like this. So this is Y, this is X axis, and the graph will be this one, and then a curve a little bit. Okay, for most tensile testing of materials, you will notice that in the initial portion of the test, the relationship between the applied force and load and the elongation the specimen exhibits is linear. In this linear region, as shown on the graph, the line obeys the relationship defined as a Hooke's law, where the ratio of strain to stress is a constant, or E. E is the slope of the line in this region, while stress is proportional to strain and is called the modulus of elasticity, or that the famous one will be Young modulus. So, the graph for the Hooke's law is, this is the y-axis and this is the x-axis. So the graph will be go higher like this, and then a little bit bend, a curve. So this will be the break or rupture point. So that's it all from me. Thank you.
Hi, my name is Jalaluddin bin Muhammad Aris. I will explain about the theory of tensile test. Theory about tensile test. A tensile test, also known as tension test. Tensile tests are simple, relatively inexpensive and fully standardized. By pulling on something, we will very quickly determine how the material will react to force being applied in tension. Being pulled, we will find the strength along with how much it will elongate. A good complete tensile profile will be obtained like the figure. A curve showing how it reacts to the force being applied and produced. The point of failure is typically called its ultimate strength or UTS on the chart.
Hi, my name is Anwar Hassan bin Hashim. My matrix number CD190062. I would like to present of the tensile test observation. First, we need a way directly being able to compare different material, making the strength we report independent of the size of the material. We can do that by simply dividing the load applied to the material by the initial cross-sectional area. We also divide the amount it move, means displacement, by initial length of the material. This creates what materials scientists refer to as engineering stress load divided by the initial cross-sectional area, and engineering strain displacement divided by initial length. By looking at the engineering stress and strain response of the material, we can compare the strength of the different materials independently of their size. Okay, this experiment need two objects, which means mixed steel and aluminum. So these both specimens were being pulled at the constant rate 5.35 mm per second downwards. When the specimen were pulled by the testing machine, thickness of the specimen will be decreased slowly because of the stress and strain. The time taken for the mid steel fracture was longer than aluminium.
My name is Haikal Hazib bin Rosham. I want to explain about calculation tensile test.
Calculation for tensile test. First, we need formula for Young modulus. The formula is stress over strain. Second, formula for elongation. We need final length minus original length divided by original length and times 100. Okay, third, formula for reduction of area. First, we need original area minus with final area divided by original area and times 100%.
Hi, I'm Jasbir Singh, son of Sarjit Singh. My medical number is CD19009. In conclusion, our experiment was a success. We are able to collect data from each specimen using universal testing machine in our lab and interpret the data to evaluate ultimate stress, fracture stress, person elongation, person reduction in area, elastic modulus, and modulus of toughness. First, the output data from the steel specimen was not consistent with the two other specimens. This is likely not normal steel material behavior and is most likely due to some artifact in the steel material or a human error when setting up the machine. More setting will need to be done to confirm this. And secondly, the person reduction of area for each specimen calculated to be equal to 22%. This may due to the fact that initial cross-sectional area of each specimen were equal. Thus, will the person reduction of area. Based on the data is received calculation, it can be concluded that aluminium is the most ductile material. Steel will undergo the most stress before fracture and brass will elongate the most before fracturing.